So here's an example of a polymorphic setup that we might have here. So we can use polymorphism through interfaces, and that's where we might see it a lot, because we'll say that this set of objects can have this behavior. All right, so that's how we use an interface, but the way it's actually implemented might actually change. So here's a bit of an example. In fact, let's do this example just by doing some code, shall we? So we'll jump over to NetBeans, and we will create a new project here. We're a new Java project. We'll call it Polyfun. So we have our new Polyfun project over here, and what we'll create is a new, rather than a Java class here, we'll create a new Java interface here. The main difference between them is that it'll have interface rather than class. So let's call this speaker. So see the main difference here, rather than being public class as it usually would be, we now have public interface written in here. And so what our idea here is that we're going to have this speaker class, and it is going, well, it's not a class now, it's an interface. It'll have one method, and it will return nothing, and it will be called speak. So our speakers speak, and I'm just going to get them maybe to print something out, but they don't return anything here. So public void speak. Notice I put a semicolon on here, so it doesn't have a body to this. In fact, if I try to put a body with some braces on here, we get an error message saying interface abstract methods can only have a body, right? So interfaces are abstract. So I'm going to get rid of that and put a semicolon on the end of it, right? So no braces, no empty braces. That doesn't work. Needs to be just like that. So no body. So it just says that something that is a speaker interface will have the method speak associated with it. And I'll use polymorphic referencing to be able to figure that out. So if we jump over here, we'll go over to our create a new one of these. Let's go new Java class, and we'll create another dog class over here. We'll have our dog, and we'll say rather than extends, what would we call? We call it speaker, right? So we can't do that. So we can't extend it. We need to implements speaker. So now we have an error message here saying that does not override the method speak in speaker, right? Because now it's a class. So we want to be able to say public void. So we need to match exactly what speaker is in here. Public void speak. And we give it a method body in here. So now we have a method body. We need to do something useful. So let's just system.out.println. What sound does a dog make? Well, we said a poodle goes yap, but let's just say that he goes woof. Goes our dog. All right, so we've got our dog here. We get this yellow underline in here, suggesting that maybe we should put an add override annotation in. So let's do that. So now we have our dog and our speaker. So we have our dog and our speaker. If we go back to Polyfun, just got the main method in it. So we can do something like dog d equals new dog, and then do d dot speak. Right, if we run that, should be fairly obvious. It says wolf, right? Because a dog goes speak. But what we could do is we change this to be speaker. And that's okay because a dog is a speaker, so it's a bit like inheritance because we use the implements. And we can still say d.speak, run that. All right, it says wolf. All right, Trent, you're saying this is all very, very obvious. We go speaker s equals new speaker. Well, it says speaker is abstract, right? This interface is abstract, cannot be instantiated. So we can't do that. So we can say speaker D equals new dog, but speaker S equals new speaker won't work. Cannot instantiate an interface. Okay, so this will not work. We can't do that. To make things interesting, let's create another class. Let's call it Java class. Let's go with lecturer. We'll get this one to implement speaker as well. And once again, we get this error message. Lecture is abstract, needs to override the speak method. So remember, programmers, we're lazy. Click on the little balloon, say implement all abstract methods, and it implements it for us. Get rid of this default. And this one will go system.out.println. And what does a lecturer say? Lecturers say blah, blah, blah. Now, that's a different implementation to what dog has. Dog has speak, goes woof, lecturer says blah, blah, blah. So, back to Polyfun. So now if I have a speaker, S equals new, let's go with dog to start with. And here we say S dot speak. If we run that, we should get woof coming out twice. So woof woof. Now if we say S equals new lecturer, S dot speak. Now, hopefully it's obvious that it's going to, we've said it's a lecturer this time, so it should be able to speak whatever a lecturer speaks. Let's just double check, run it. Yes, so we got woof and we've got blah blah, which is what we want here. But to the compiler, what it needs to do is to go, well, S is defined as a dog at this point, and S speak does something, but when I call S speak again, it is something different. So this is a polymorphic idea that we have. So let's define some more in here. So where it really becomes interesting is not when we're sort of defining these individual variables, but let's say we had a speaker array, so an array of speakers. So equals a, so how do we define an array again? Something like this. Equals a new speaker 904. And we say SA0 equals new, we could say dog. Let's create another. So here we got, what do we got? We could have a lecturer, and let's create another type just to make it more interesting. So new Java class, let's make a student, and we'll get them to implement speaker, implement all abstract methods. Now, this is a bit hard because you're not here, but system.out.println print line. But what does a student say? Student says nothing. I can't hear you. How about student says, can I have an extension? That's what I hear students say quite a lot. So can I have an extension? Let's go over to here, back to Polyfun. And let's just cut this and paste this a few times. Let's say 1, 2, 3. Make this one a student. Say 4, a lecturer, student. Make a dog at the. Make this one a dog. All right, we'll run this. Oh, I get an array index out of bounds. Right, so hopefully you picked that one up. We have this is 4 and this is 4 here, so that's too large, isn't it, right? 0 based indexing. So it means that the largest we've got here is 3 if this is 4. Run that. Right, so that compiles, but this is the output from above here. And so now what we can do is we can use one of these enhanced for eaches, and we can say I want a speaker, right, because that's what's in here, and val is equal to my array. And then because all of these are speakers, I can guarantee that they will have a speak method. Now we have, what do we have? We had a dog, lecturer, student, dog. So a woof, blah, blah, blah. Can I have an extension? And woof. So each one of those will have different implementations of it. And this reference here is polymorphic, because we don't know what it's going to be. I mean, it could change. And each time around this loop, it does in fact change for the speaker.